In this video, we'll successfully complete a hypothesis test with the t-statistic. So we'll be using the formulas, we'll be using the new table, and we will go through the steps of the hypothesis. First, just to show you before we get started, how you determine what your critical boundaries and that critical region are for the t-distribution. So here, for degrees of freedom of 3, our critical boundaries are going to be negative and positive 3.53, giving us 5% in each tail for a two-tailed test. Now we do that by looking at the new table. All right, so this is the table that you want to look at. It's called the t-distribution. And if we come down here, remember that diagram said that the degrees of freedom were 3, and we go over here to this row, and we look here, it said that each tail had 5% in each. So if we take that 5% is a 0.05, are we talking about here or here? This one says proportion in the two tails combined, and here's proportion in one tail. So 5% in each tail would be 0.05 in one tail. Combined together, that's 0.1. So that's where that 2.353 number came from. So the hypothesis testing is going to be the same as we did with the z-test. Remember I said those 4 steps we were going to keep coming back to. So state the null hypothesis, locate the critical region, calculate the new test statistic, and make a decision. So we're going to go through those steps. And again, what we're talking about here is we have a population before the treatment where we know that population mean. They undergo treatment, and then afterwards we don't necessarily know. We want to know what did that population mean change. So the first 2 steps are stating the null hypothesis and alternative hypothesis and selecting an alpha level. So here's the example that we're going to go with, and if you haven't already, make sure you go back to the modules, print out the teacher and student-led examples, and have that with you so you can work through the problem as I do it. All right, so first we're going to state the hypotheses and select an alpha level. So here's kind of a shortened version of that. If it looks, it says a group of 8 individuals, so that means we have an n of 8. Are being given an experimental procedure, and the population is normally distributed with a mean of 6. So that means our mean is 6. So if we were to go ahead and make a hypothesis, our alternative, our null hypothesis, is going to say that the mean of the group that was tested is going to be the same as the population mean. So here the mean for the test scores is the same as the population. And really this subscript could be a variety of different things. Sometimes you'll see me call it the treatment group, variety of different things depending on what the example is. So the alternative hypothesis then is that the mean of the treated group is different. And so the mean of the test scores in the treated group are not the same as the population mean. So, and is this a two-tailed or a one-tailed test? I'm not really applying any directions. I'm just saying that it's different then, right? And you can see here, the null is that it's equal to the population mean, and here it's not equal. So there's no direction implied. It's two-tailed. And we're just going to go ahead and set up our alpha at a 0.05 level. So now we need to locate the critical region using this t-distribution table. So I have a little snippet of it here. We need to remind ourselves that we're using degrees of freedom and what degrees of freedom is. So we're going to take that sample size, and our sample size was 8, and we're going to subtract 1. So 8 minus 1 gives us 7. So then we're going to go over here, and we're going to find 7, and we're going to go across. See, how far do we need to go? We said we were going to do a 5% significance level, which is 0.05. We said it's a two-tailed test, so now we're going to break that 0.05 like we did before. We break it into 2, which means in one tail, here's 0.025, but this table is nice, where it tells you the proportion in the two tails combined, 0.05. We come down here, and 2.365 is our critical T. So here, that's what this is showing you here, 2.365 is our critical T for degrees of freedom of 7. So again, this is our critical region out here and our critical region out here. These boundaries are defined by our critical T, plus and minus 2.365. So now we need to calculate that T statistic. So we're going to have to do our X values of 14, 13, 8, 6, 5, and 10. And then we need to get our X squared values, which are So now we need to get our X squared values. So 14 squared is going to be 196. 13 squared is going to be 169. 8 squared is going to be 64. 6 squared is 36. 5 squared is 25. 10 squared is 100. And 6 squared is 36. So then we add those together to get our sum of X, which is going to be 72, and our sum of X squared. So I've added all these numbers together to get 72, add all these numbers together for the sum of X squared, and that equals, 726. So now I need to plug that into this formula. So sum of X squared, which is, oops, I didn't put my squared there, is 726 minus 72 squared over, and my n is 1, 2, 3, 4, 5, 6, 7, 8. And I'm just going to give you the short answer, which is 78. So then I'm going to plug that into my variance formula. So my variance formula is S squared equals our SS, which is this value, 78, over. Now I need to use my degrees of freedom. So if n equals 8, my degrees of freedom are going to be 7. So over 7, so my variance is 11.14. Then I can plug that into this formula. I can either then just take the square root of, so I'm now going to use this formula. So my expected standard error is going to be the square root of 11.14 over, now I'm back to using n, which is 8, and that's going to give me 1.18. Now, now I need to calculate my t value, my t-score. So I'm just going to erase these numbers out here, so I have some space to do it. And my t statistic is going to be the sample mean here, which was 9, minus our population mean, which was 6. So this is the measured difference between the sample mean and the population mean. And then I'm going to do my expected difference, which was 1.18. And when I calculate that out, it gives me a 2.54. So next we need to make a decision regarding the null hypothesis. So remember we said for an alpha of 0.05, degrees of freedom of 7, using that new table, that our critical boundaries were plus and minus 2.365, giving us 0.025 in this tail probability and a probability of 0.025 in this tail. So now my calculated t-test, or my calculated t, was 2.54. So now we need to decide, is 2.54, is it over here, or is it out here? 2.54 would probably be right about here, maybe a little bit closer over. So what's our decision? We reject the null hypothesis. Our value, our calculated t, falls in that critical region. The next activity for you guys is to do the Kahoot and then the student-led example.